What's up, hackers? Welcome to Attack on Tuesday. My name is Taggart, and tonight, as the repo might suggest, we're going to have some bad ideas. But specifically what we're going to be doing is we're going to take a look at continuous integration and continuous delivery, CI/CD pipelines, and how they can be used for evil. Thinking a lot about this, I'm doing a lot of cloud stuff at work, and in particular, we know that there was some of this going on with the recent Lapsus disclosures. Disclosures is the wrong word. Illegal leaks and illegal access. Lapsus is a weird animal, right? Because they're not really a ransomware gang. They're not dropping ransomware. They're just stealing stuff. So I guess they're just thieves. But that's what we're going to do today. We're going to talk a little bit about CI/CD. So what Lapsus did is, with regard to CI/CD, is they were actually able to compromise a Microsoft CI/CD pipeline. Oh, wow. Right off the top of the bat, Brian, thank you so much for the raid. Really appreciate that, friend. And good to see you. Good to see you on Twitch. Longtime fan of the podcast, by the way. Friends, if you are not listening to Breaking Down Security and you're not following BreakSec everywhere you possibly can, you are missing out on some of the best conversations in the information security community. But yeah, really cool to see you on Twitch. Really cool to see you join us. We're a great group here in the live world. But yeah, so we're going to talk a little bit about continuous integration and continuous delivery. Now, I know that I do this kind of weird thing where I assume that security folks know about development stuff, and I should stop doing that. I weirdly have had a finger in both pies for a long time, so here's what's up with continuous integration and continuous delivery. So traditionally, let's think about how you would deploy software, even to a virtual machine, right? Maybe you'd have a Git repo, maybe not, but let's say you had a Git repo, and you were going to deploy that code to a virtual machine in development or production. Okay, so you push the code to the repository. Hopefully it works. Maybe you did some unit testing and some integration testing before you pushed it. Should have done that, but maybe not. And then you go ahead and send that code off to your production servers. All of that is a manual process, what I've just described, which sucks. Just got done getting your butt kicked with THM with SSRF. Man, server-side request forgery is weird. It's definitely like my least favorite web app thing to do. I really don't enjoy doing SSRF. It's always weird, it's always finicky, and what you can do with it, except in very, very rarefied circumstances, is always pretty limited. It's definitely cool to do, but it's always like, oh, well, if you do this, maybe you can do this other thing. It's like a pivot opportunity more than it is, a one and done. But yeah, so that's how things used to be. Now let's imagine, in addition to the manual effort being really tedious, imagine doing that at scale, where you have a multiple virtual machine situation where you are replicating the application across different regions, right? Maybe it's a database where you have different shards of the database to improve performance and to improve availability and integrity. You can't do that with human effort, right? So instead, what you want to do is, as the DevOps folks say, treat your infrastructure as code. And in this case, you want to actually treat your code as automation. So what CI/CD attempts to do is automate through scripting and other tools the entire build pipeline from getting your code off your machine all the way to your development or production environment, whatever it happens to be. So you can bake all sorts of stuff into this. You can bake in your unit testing and kill the pipeline if the testing fails. You can create different artifacts as you're building. So for example, I've got bad ideas here, but let's go take a look at another repo where I'm actually using CI/CD for real. Let's go take a look at good old Offensive Notion. And for those of you who are not familiar with Offensive Notion, it's my and Husky's project. We've created an entire C2 framework that uses Notion as the communication medium and uses the Notion API actually as its communication channel. So it doesn't look like anything but Notion on the endpoint. But we build this thing using GitHub Actions. Now, we build it ourselves anyway, but when we look at our GitHub Actions, and we'll talk a little bit more about those in just a minute, all of the build pipeline, as you can see, is described in YAML. Hey, John. Good to see you. All of the build pipeline is described in YAML. So we have some scripts that we run. Right, for Linux, it's really easy because we do cargo build to release. We're using Rust up update stable, so we basically run Rust up right away. And happily for us, it's actually already installed on the virtual machine that GitHub provides for us during the build process. Hey, Nopix, good to see you. And from there, we do the build on Linux. It's super easy. And then we do the upload artifact. And what that does is we say, okay, it's going to be at this path relative to where we're doing the build pipeline, agent target release offensive notion. We're going to call it offensive notion Linux AMD 64. And at the end of the day, what we get is the build artifact. So when we push a new version, right, to the main branch, see this here? When we push a new version to the main branch, we actually get those builds happening automatically, so we're ready to give you those downloads right away. Same thing with the build on Windows. It's actually way easier on Windows. Well, no, it's not. But notice that we're actually building on Linux for the Windows because we just use the MingW library to do Windows build, because it's way easier than handling Windows. And there's another reason we don't build offensive notion on Windows, and I'm wondering if anyone chat can hazard a guess as to why we don't build this tool on Windows. On the Windows VM that they will spin up for you if you want to use a Windows VM to do your automatic builds. And as always, if there's anything that I'm mentioning that doesn't make sense or you're not sure about what's going on, please ask the question. It's not signed. That's a really good thought. Luckily, I don't have to have it signed in order to build with the Rust pipeline. If I were using csc.exe or .NET or whatever, right, MS Build, if I were using those built-in tools to do my build pipeline, you're absolutely right. I would need to have an MSDN account and do all that. And I could go through that process. But in this case, memory protections? Kind of. I'm building an offensive security tool, and I don't have control over the defender state on this VM that they're spinning up. Hey, Husky. Good to see you, bud. I don't have control over the defender state on this VM. Why would I give Microsoft free samples of my operating or my offensive security tool as it's getting built? No, thank you. Husky, how was dinner? Have you finished the chicken souvlaki? Yeah, I mean, I could do it, but why bother? You know what I mean? Now, that being said, we're going to try. We're going to try to do some fun stuff with a Windows machine in a little bit with this. Ah, very cool. Very cool. All right, so this is what GitHub Actions look like. There are other CI/CD pipelines, certainly. Back in the day, people were really about Travis and Circle CI. Folks still use that too. But GitHub Actions, at least in my experience, has sort of eaten the market. And the reason why is because it's free, question mark, at least to some approximation, right? You can do some GitHub Actions with a free account on GitHub. So why wouldn't you use it? Al says he misses me. Aw, I miss him too. I miss his Raiders, I'm not gonna lie. But, you know, I also miss him. Okay, so we're gonna put one of these together, and I just want you to think about this. Again, let's think like an attacker here. Okay, so during a build pipeline, a virtual machine gets spun up that we can run arbitrary commands on? To me, that is the first thing I want to try to do, is get myself a shell on that machine. But how are we going to do that? Because obviously this thing is in kind of a rarefied environment, right? It's getting spun up on Microsoft's infrastructure, all of that stuff. It is possible. We're just going to have to be a little bit clever about it. The first thing that we're going to have to be clever about is the fact that this is a real deal network, right? It's not try hack me. It's not hack the box. Okay? So, oh, hey, Chad. I've got the entire ski lodge in here, I guess. It's a real deal machine on somebody else's network. Oh, Chad, thank you for the gift sub to John Donaris. So how am I going to do this? And in terms of permissions, right? In terms of like the terms of service, like I'm running my code on it already, right? And I'm not going to be attempting to move to other tenants and trying to break out. So to at least a first approximation, I'm going to stay within my rights and the terms here for what we're going to try to do. But let's start thinking about how we are going to use GitHub Actions to try to phone home. The first thing I need to solve is that networking problem. If this thing is on a network that I'm not in, how do I proxy down to my machine? I could, of course, spin up a cloud attack box, certainly an option, right? I'm going to be lazier than that, though, and I'm going to use ngrok. So if we're not familiar with ngrok, oh, Chad, thank you so much for the gift to Nopex. Really appreciate that. So ngrok is kind of cool. Basically, what it does is it creates a point-to-point TCP or HTTP proxy that you can use to forward traffic to a local machine, right? So ngrok will spin up for you in however you want with whatever port forwarding you want, and then you're just like, good. Let's watch ngrok in action first, and then we'll see how that goes. So I'm gonna do ngrok TCP on quad 9s. And you can see that I'm already started here, right? And the reason why that worked is because I already configured ngrok on my Kali box here to do what I wanted to do. Now, take a look at the data that I'm getting from ngrok. It tells me about my session status. It tells me about my plan. I'm not paying for anything here. And I've got my web interface on 4040. That would be if I like wanted to see what's going on with ngrok in a web interface. And sure enough, I can do that. Right? That's fine, but that's not actually what I want. What I want is this right here. That there's TCP traffic getting forwarded to my local host port quad 9. Good chat. Are you okay? Thank you so much. 10 subs. Good God. Look at those subs coming right in. Thank you so much, friend. Really, really appreciate it. Those WinterCon attendees are in a generous mood tonight, I guess. That's very, very cool of you. You're testing a theory? Is the theory that I will get a tattoo? Because I promise that that's not going to happen. But let's go ahead and set up a netcat listener on quad 9 here. Okay, now over in this is my host machine. Let's create a new terminal window here. Let me zoom that in just a little bit for everybody to see. And let me split that just because I don't like wide terminal windows. I don't know why, unless I have to. Okay, so I am on my Windows machine here. Boost active stream and build a crowd. Yeah, I saw that email from Twitch too. That hype train stuff will now put your stream in high viewership areas of Twitch and theoretically increase viewership. So I appreciate it. I appreciate you helping me test that theory. Okay, so again, I'm here in, this is WSL, right? This is functionally a different machine from my Kali VM, which is here. So what should happen is if I netcat from here to here, Husky's got me, or somebody got me with the admin ABC123. Thank you to whatever friend of mine just sent me this message over Netcat. Really appreciate that. So let me see. Let me go over to WSL here, and I'll do netcat, and I have to change up the syntax just a little bit. Okay, so now I should see a connection received. Let's see what happens next. And connection ended. I'd already captured. It's one socket per. Let me try that again without those goofuses messing with me. There we go. There's the high. So I'm able to send data from one point to another. That's the deal. Okay, so the first thing that we want to try to do is use this technique. On your word, that was not I. Okay, was it Al? We want to try to use this technique to get a shell out of a GitHub action. So the first thing I'm going to do is in my bad ideas repo. The first thing I'll do is clone it, just so you can see what that looks like. And I like using SSH to clone. So let me make a new window here, cd documents. I don't have a demos folder, so we'll just go into demos. Okay. And then we will git clone. Yeah. Thank you. Okay, so I'm in bad ideas. There's nothing here, really, but just to prove that I can do stuff, let me vim the readme.md, and let's change this to a capital B. Okay, git commit m, fix capitals. By the way, chat, would there... Oh, God, right, because I've never done this before. Git config from my Kali blocks, global user.name. Yeah. And user.email. Okay, let's try that one more time. Cool. Git push. So yeah, the question I was asking was, would there be interest in a stream or something specifically about using Git? Because I know we talk about it a lot, we use it a lot in things like this, but this isn't a development focused stream all the time, right? So we don't always get into the nitty gritty about how Git works and why. If there's interest, we can do it. Git good. Yeah, exactly. All right, so obviously that's working. I have the ability to push changes to the repo. Fantastic. Now, the first thing I need to do is enable GitHub Actions on this repo. In order to do that, I'm going to go over to Settings and Actions and General. Okay, allow actions. Okay, everything looks good. Now I got to go over to Actions. Sin, by shell out of a GitHub action, you mean add the line to connect the IP import after pushing the code? Kinda? You'll see what I mean in a second. I promise it will become clear. So we're going to get started with GitHub Actions. And we're going to create a simple workflow. What this actually does is it creates a commit. You can see that it's actually creating a .github folder in my repo and a subfolder called workflows and called blank.yml. And we'll just call it badidea.yaml. Okay. And notice that we have this YAML stuff that says here, okay, a workflow is run made up of one or more jobs that can run sequentially or in parallel, runs on Ubuntu latest, love it. And then right here, if you're thinking like a hacker, echo hello world, if I can do that, what else can I do? What else can I do? Well, let's go ahead and start this commit just now, and then we'll see what else we can do. Yep, that's good. We'll leave that as it is. Commit directly to the main branch. Fine. Commit new file. Awesome. Yeah, you see it now, right? Okay, so now you can see I've got this GitHub workflows. And see this little guy right here? There's a build happening. Let's go check it out. So this is a GitHub action. And it's running. It's doing its thing. Notice that it ran a one-line script and run a multi-line script. The build succeeded. Great news. Right? No errors. Now, if I want access to this YAML file for my own purposes, I have to pull, because there was now a commit to the main branch. I have to get pull to get that information. Sure enough, there it is. Okay. And here is our build script, which we are now going to change. We are going to delete the one... actually, let's run... So this multi-line script uses a pipe, and then you can put as many lines as you want on it. That's fine. But we actually don't need to do this. Just say echo when done. Right? And yeah, let me split this off here. And we'll do ngrok TCP quad 9 up here. If folks could leave that well enough alone for a moment, I'd really appreciate that. And we're going to echo hello world. No, we're not. We're going to run. We're going to delete this line. Delete this line. We're going to say echo all done. And the reason I want this in here is so that there's an extra command to run after the reverse shell that I'm going to try to run here. Execute reverse shell. And by the way, I should say, I have no idea what's about to happen. This was an idea I had 2 hours before the stream, and I wanted to see if it was going to work. It probably should. I have seen repos that are like, yes, you can get a reverse shell out of GitHub Actions, but I have no idea what's going to happen after that. So definitely a live demo. We are making sacrifices to the demo gods as necessary. All right, execute a reverse shell. Obviously, I'm going to need some of that, so I'm going to pop over to my pen test profile in Brave, not to use it, but to go get my hack tool extension that has all the cool stuff that I need for reverse shells just ready for me. And I can grab this data and put it in the extension. Oh, by the way, I can just open it. I don't have to use it through that. I can do it through... Oh, boo. Yeah, I used to be able to do it through here. I swear there used to be a way to just, like, open it on the side. But, okay, whatever. Okay, ngrok, and what was the port? It was 11973. 11973. Okay. And we'll do the old school right here. We'll do this one. And we'll see what happens. Of course, I'm going to have to NC quad 9. And we're going to run exactly this. We're going to see what happens. So we're going to save that. And git commit am Test rev. Git push. Okay. Let's take a look at our code here. Pushed. We see the action is running. Test rev. Ooh, execute reverse shell failed. So let's find out why. Cannot remove temp F, no such file or directory. Interesting. So we can try to get rid of that first RM. And because temp F, if it's not there, if that fails, make first in, first out. We can start with the make first in, first out because we know it's kind of a fresh environment. So we'll do that. Now, chat, is there anyone who is unfamiliar with this reverse shell shell command here that we're trying to do? Or even what a reverse shell is? Let's talk about both of those. And let me see if I can actually define a reverse shell right without accidentally defining a bind shell, which is usually what ends up happening. So, a reverse shell is useful because we can't open arbitrary ports on our target machine that we're trying to gain access to. Host-based firewalls and network-based firewalls will prevent us from doing so. So that's not going to work out. But in most cases, outbound firewall rules are much less restrictive because you never know what kind of ports you're going to need open for communications initiated by the host out to the wide world. For that reason, what we want to try to do is if we can get some kind of code execution on the machine, what we will do is we will initiate a TCP conversation from that machine out to a listening server that we control. That listening server will pick up the conversation and then establish a communication channel between those two. In the case of a command line interface, we would refer to that as a shell. Now, the truth is that RDP, like remote desktop, is a shell too. It's just a graphical shell, but whatever. That's the idea of a reverse shell, where we initiate the conversation from the target and listen on the attacker. A bind shell, which is way harder to do these days especially, is the other way around, where you listen on the target and you initiate the conversation from your attack machine. That's, again, harder to do because firewalls are going to usually prevent you from just opening rando ports over on the machine. Okay, so we're going to try to not do this remove tempf because that's what failed here. Okay. So what we're doing with this MK FIFO, and if you're unfamiliar with this, it's kind of cool to see. Let's man MK FIFO or FIFO. I don't know how you're supposed to pronounce it, but they're named pipes. If you've ever heard about named pipes, that's what they are, and they're first in, first out data structures. First in, first out. Okay. So they're the opposite of what we, a LIFO or like a stack, right? A last in, first out. So a last in, first out data structure is like a stack of plates, right? As you put them on, the last one in, as we pull it off, is the first out. But FIFO is actually the first in, first out, meaning the first piece of data comes in, then the next, and the next, and the next. And we're actually like pulling from the bottom of the deck as we pull data out of it. That's how a first in, first out pipe works. And what we're doing with that here is we're establishing the socket, okay, for the communication between server and client using Linux command line tools. The socket exists because as a file, because it's a Linux file system and everything is a file, or it's a Linux operating system and everything is a file. And then we are using... You're going to blast your stream audio on the house's sound system? Well, it's pretty good tunes tonight. So enjoy. You'll also hear FIFOs referred to as queues. Very correct, Neon. So that's the socket that we're making. And what we're doing is we are, now that you've told me that you're going to stream my audio, I'm trying to like smooth out the voice. Welcome to Taggart Radio, caller. Where are you calling? Where are you calling from? All right. So we're catting that queue, that socket to bin sh, and then we're joining standard in and standard out. And then we're sending that to netcat. You have low standards. Yeah, but I don't. And then we're sending that, whatever the response back is, back to tempf. So you can see how we're getting that first in, first out data set. That's how our reverse shell works. So we're using netcat to actually make the TCP connection, but where is the data coming and going? It is going to this tempf, which is our socket. That's what this command is broken down. You may have seen it used a million times in demos, but that's actually what's taking place with it. Okay, so I'm gonna quit out of this man page and save this up. All right, let's try this again. Git commit am. SM Flores, good to see you and welcome. We are trying to exploit GitHub Actions, automated build processes, in order to gain a reverse shell on the virtual machine that GitHub spins up for us to build our code. Just to see if it's possible, because we know that these CI/CD pipelines are really great for automation, but also there are a lot of things that maybe you shouldn't be able to do with them, and this may be one of them. And it's also a threat vector if you don't control access to your build pipeline carefully. Okay. What did we do? We removed the remove. So we'll push that. And, ooh, I gotta start listening again. And come back here. Okay, this is already building, right? So we'll see what's up. Run actions. We're not at execute reverse shell yet. Oh my god, there it is. And I just elevated to root. So I have root privileges on a GitHub Actions box. Well, that worked a little bit better than I expected. Okay. So here's a fun idea. What if you set up this in order to, I mean, this would be a total breach of terms of service, but what if a criminal did this to actually spin up attack infrastructure with a constantly changing IP? And I bet this looks like a Microsoft IP. Yeah. Let's find out. .40.83.6.233. Let's do a who is on that and see who that is. All right, so things that we know so far about this. We know that it can hit... No shot? What do you mean? So, you can make yourself look like Microsoft. So in terms of indicators of compromise, you've already knocked out. I was fairly confident it would be a Microsoft IP, because I know this is running on their infrastructure. What's this OS? Sarwan, I'm running Kali Linux. That's what you're seeing here. Although, great question. This should be Ubuntu. What is my build machine? It is Linux for Azure. So it's Linux. So it is on Azure and it's Ubuntu. Living off trusted build pipelines. Boy, now there's a talk that might be fun to give, huh? Okay, so we know also that it can hit arbitrary. Internet targets, right? If I do ping c4 taggerttech.com, that should resolve. No? It did resolve to the IP address. So it's resolving, but maybe, oh, crazy. Maybe ICMP outbound is blocked. And that would probably not be blocked by a host-based firewall. That would probably be blocked by the Azure network security group that this thing is built with, right? But we can check. Yeah, UFW is IP tables. What is it, L? Oh my god. It's not. It's just... Okay, I didn't expect that. So it is actually using IP tables. Oh, well, you know curl is going to work. Yeah. Yeah, that works fine. Well, let's take a look at the IP tables rules, which we, as root, can then change. Chain forward, policy drop. Docker user. Okay, Docker isolation. Are we in a Docker container? It would make sense if we were. It would be a Docker container running on a VM the other way around SMFlaris. But yeah, I think we would have to be. What am I actually doing? So let's back up. We have this GitHub action running right now, right? This automated build pipeline. I have gotten a shell, a command line interface on a machine that I do not control, right? Because it's part of my GitHub action that is triggered anytime I push code to my GitHub repository. What happens in a GitHub action is GitHub spins up some virtual infrastructure for me to perform any commands that I've configured. I have configured this command to actually give me a reverse shell, and it's working. And so now I'm learning a little bit about what this environment looks like. And it looks like it's a Docker container. Let's confirm that. Okay, I don't see... I don't see a Docker env. What's in image generation? Interesting. Thank you for the follow, Sarwan. Do we dare? Yeah, we do. I'm not going to try to crack that hash, but we do know that runner admin has one. Pretty wild. That's a giant. That's a SHA-512 hash, right? I'm pretty sure. So good. Now. Okay, stop. Yes, it was a missed sound effect, Husky. Okay, so I actually think we had it reversed. Okay, so this is it's not running in Docker. It is running Docker. Meaning that the IP tables rules that we saw were for the Docker daemon running on this straight up virtual machine that we are connected to as root, by the way. Ginger, your comment was held off for bullying, but I'm going to allow it. It might also be running Docker inside Docker. Unlikely. The way that you would do that generally, SM Flores, is that you would mount the Docker socket. Like this is how Watchtower does it. You mount the Docker socket from the host inside the Docker container. It's pretty weird to do that, though. I don't think so, and here's why I don't think that's what's going on, SM Flores. For one thing, the documentation for GitHub Actions tells us that it's a virtual machine, not a container. That's one thing. The other thing is, look at this. I mean, we have, and also we had other users, right? But we had sudo privs. I'm pretty sure this is a virtual machine. And last thing, we didn't see the telltale Docker env in the root of the file system that we would normally expect inside of a Docker container. And just to show you what that, I have Docker running here. So if we do Docker container run rm it Ubuntu, and we'll do bin bash, right? How did I not have Ubuntu locally? All right, whatever. So that'll do its thing. Okay, so over on the left-hand side of my screen, I am in a local Docker container. I would expect to see this .docker env. Maybe peek with Docker exec. Docker exec does not work on images. It only works on containers. We can do Docker container ls to see if there are any running. And there are not. So I guess we can run exec to fire up, and we could run one of these images with Docker container run. But these are straight up like signed images, right? They're, look, Node, Ubuntu, Debian. These are kind of, they're trying to make educated guesses about what you're going to do with your build pipeline. That's what we're looking at here. All right. So let's look at that IP configuration again. Is it the same worker for every build, or does it get discarded? No, it gets discarded. Born Again Shell. Once your VM is done, it brings it down. At least I think so. Although, you know, now that you mention it, it comes up so fast. There's got to be some kind of caching or something going on. Because I mean, provisioning a VM in Azure is fast, but it ain't that fast. You know what I mean? This, like, within a minute of me pushing the code, this build is started. The real question is, when does the lifetime of this VM run out? As far as I understand it, I mean, there should, hold on, that's a great question. Let's see. GitHub Actions timeout. So I bet there is a top limit. To add a timeout, they might have builder VMs queued, maybe. Hold on, time limit maybe? Okay. Each workflow is limited to 72 hours. And yeah, let's talk about billing. GitHub Actions help you automate. About billing for GitHub Actions. Yes, please. So, in terms of what you get, I'm a GitHub Pro, so I get 3,000 minutes per month. GitHub Free gets 2,000 minutes per month and 500 megabytes. I'm not even touching this. Your minute multiplier on Linux is 1, on macOS it's 10, and Windows it's 2. So you're using double your time if you use a Windows machine, and you're going 10 times if you use macOS. All right. Oh man, we've got a Griff song on. That's awesome. So yeah, Husky. No kidding. Like, have you ever done this before? Because I just had this idea today, and I wasn't sure if anyone had played with this in depth. Where are we? We're here. Okay. So look at our ETH0. We've got a 10 Azure Pipelines timeout at 30 days. Yeah, exactly. So our ETH0 is 10.1.0.4. We're obviously in an Azure private network. Okay. And I still can't ping anything. But this one, it says destination host unreachable, which may be an IP tables thing. Al says he does a similar thing with Python sandbox apps. Yeah, that would make sense. And actually, the other thing that I thought we might get to tonight, we may not, is Azure DevOps, which is what Lapsus actually compromised for Microsoft, was their Azure DevOps stuff. Replit, so Replit is an interesting one. Replit actually has better controls than this in order to do this kind of stuff, because I've tried to do it before. Nightbot has a similar sandbox where you can... Hey, Sar. Yeah, so, like, that's a bit of a tangent, but we can play with Replit at some point. One of the things about Replit is that you can't actually install a lot of packages here, but I have like... I have apt on this. Look at this. I can install any package I want. Bitbucket Pipelines is the same thing as GitHub Actions, just for Atlassian. And GitLab has the same thing as well. Yeah, so for me, like, a couple of things. Obviously, you can automate... your... build your spin up of an attack environment, right? You could automate that inside of your literal GitHub action. You could do that. And then, you know, get the callback from ngrok or whatever proxy you want. By the way, another project that I have in mind is we're going to build an ngrok clone using Nginx and WireGuard. It's going to end, you know, a DigitalOcean droplet or something. It's super easy to do and really, really fun. Thank you, Nginx and ProxyPass. But, okay, so obviously, you know, I just installed Cowsay on this thing. Oh, user, games, Cowsay. There we go. It's like the last thing that installs to user games. Anyway, oh yeah, I want to get back to that IP tables. Let's read this. And I'm not the best at reading IP tables rules. What we're looking at here is the host-based firewall on this virtual machine. And it's columned, right? These are rule headings, right, for Docker isolation. We'll drop all 95, 181, 164, 182. Interesting. Okay. Now, the next thing I'm going to try is not new. So it's not like I'm not disclosing a new vulnerability. Thank you. This is the one. That. Are there any network services listening we can reach any other containers on the same subnet? Imagine if you can pivot around to other people's instances. So, Sar, that is exactly what I'm not going to do, because for sure, like, I know that I'm skirting the edge of terms of service now, but if I start going after, like, they'll even tell you, if you want to do pen testing and research in Azure, they'll, like, do whatever you want with your resources. But the second you start messing with your neighbors in the data center, you have breached terms. So we're not going to do that. Okay? I do want to know, though, about what we get from the metadata API. So, for those of you who are newer to cloud pen testing or haven't seen this happen before, what are we dealing with? So, Azure VMs and AWS VMs, they have this service running inside of them that is the metadata API, and it will contain information about how the VM was spun up. And very often it will have identities and other information that you can use to further pivot throughout the virtual environment and the cloud environment. So if we look at what we have here, we have a subscription. We have a resource group. We have, this is the name of the virtual machine, I think. No, it's not. It's the identifier of it. Security profile. Let me apt install JQ, because why not? This is not the GitHub API, Born Again Shell. This is the Azure API. We're not talking about GitHub anymore. We're actually talking about Azure's instance metadata service. So if we do that same thing we did again, and we're going to pipe it to JQ, that gives us much cleaner output, right? So there's the resource group name, there's the resource ID. It's spun up in the central US. We see the subnet that it's in. All that cool stuff. Now, what else can we do with it? So we're going to try one of these. Identity not found. Okay. So we're not going to touch the Azure Key Vault. But already some pretty cool stuff. Is there anything else that we should check before we power this down? There's other stuff that I wanted to do tonight. We are not running in a Docker container. If you want to do Docker volume ls, nothing there. Docker secret ls, we're not part of a Docker swarm, so that's not going to work. We have other stuff that we can do, though. So I want to shut this down for a minute, and we'll see what else we can do. Kill this. The build then finally moves on. Have I used Purple Panda? I have no idea what that is. Born Again Shell, that's exactly where I was going. We were going to talk about GitHub secrets. It's like Lin Peace for cloud. Oh, interesting. So again, I want to... Purple Panda. Cool. I don't know what I expected. By the way, speaking of GitHub, I don't know when this happened, but you finally have lists in GitHub. So you can add your stars to lists and organize them this way. Absolute lifesaver. And as a matter of fact, I want to see if I can get these via the API or via the GitHub command line interface and use that to automate building out new machines. All I have to do is add the repos to a list, right? And then they'll get pulled down into my scripts folder or whatever. Oh, you don't have them? You're in Eastern Europe? I am sorry about that. For those of you who don't have it, you can use one of my favorite things, which is Astral. So Astral authenticates to GitHub for you and will allow you to add third-party tags to your GitHub repos, which I also obviously have used quite a bit. And I'm starting to rebuild this list in GitHub star lists. But no, we got to talk about GitHub secrets next. Now, did this build finally fail, or is it still trying to run? It's still trying to run, which is interesting. We're going to cancel that workflow. Come on. Die. All right, it's canceled. Great. Fantastic. I wanted to see that stop. I should probably do like an end exit one in the reverse shell, right? Let's vim our YAML here. Yeah, and exit 0. That way, it'll exit correctly, and it won't freak out at me. But that's not all. Let's talk about GitHub secrets. So, again, if you compromise a build pipeline like this, if you get access to somebody's build pipeline, maybe you don't have access here, but maybe you have access to push code. Probably because NC was still listening. No, I think it's because it didn't. It's it was waiting for an exit code and it didn't get one. That's why it was hanging. Secrets. GitHub Action Secrets allow you to add sensitive information to be used during build pipelines. So that could be API keys, passwords, whatever else. And of course, this is because people get lazy with secrets in Git repositories to this day. Don't believe me? One of my favorite tools is grep.app. Let's try searching for a regular expression. Password. Now, obviously, some of this is not real. Right? Like some of this stuff for big build libraries. But as we go down, it's entirely possible that there may be legit passwords that we find in here. I also like password equals quote. That's always a fun one. Like that. Now, again, some of these are defaults that you're supposed to change. But who knows, right? By the way, anybody who's interested in looking up these and doing responsible disclosure, go do it. Easy CVEs right there. Anyway, grep.app, great tool for that. So to avoid that scariness, we use GitHub Action Secrets. So we'll create a new repository secret. We'll call it secret word. Requests for a secret word. Pineapple. Obviously, we have to leadify it. Okay. Secrets are environment variables. So again, the point would be that these are API keys that we would build with, right? And we don't have to worry about sending them even in like a .env file in the repo because they're set up in here. But then what happens we'll just let this run again. I'm really hoping I just see the shell pop. It's going to be very satisfying if we do. Awesome. Okay. Ooh, interesting. So what did we get? What does our end say? All right. Look at all the environment variables. They're really just trying to, like, there's Haskell environment variables in here. They're just trying to guess at everything you're possibly going to need. All right, let's learn more about secrets and how we didn't do these right. Accessing your secrets. To make a secret available in an action, you must set the secret as an input or environment variable in the workflow file. Review the action's README file to learn about which inputs and environment variables an action expects. Workflow syntax for GitHub Actions. Env. Aha. So that's the deal. Let's go back to our actions and kill this shell. And hope to God that my hack worked. Nope, not so much. Did not end exit 0, unfortunately. So we'll cancel that workflow. And let's add this in. So we'll add this as an environment variable. And what did we call this thing? Secret word. Secrets dot secret word. So the idea here is that this part of the environment will have access to this environment variable, which again, if we have the ability to write to the repo, we can just make this happen. New secret. All right, let's get our listener going again. Meta question. Shouldn't this stream be... it's our favorite question. Shouldn't this stream be the programming category of Twitch? Think the secret word should be an array item? I copied it exactly. Nope. It's a key. So, SM Flores, how much code have we written today? This is not a game and software development stream. This is a science and technology stream because Twitch has yet to create a cybersecurity category. And that is what we are trying to lobby for. But until that time, I feel that science and technology more accurately represents what's going on this stream, because it isn't just about programming, and it's certainly not about game development. We're talking mostly about information security on this stream. Sometimes we do programming, but it's in the service of information security. So the category will remain science and technology. Nope, there's our shell. Echo, secret, word. And there's our secret word. This is fun. I like this. We're making our own flags to get. You got the clip of secrets too, huh? Question about Windows builds. So Ming W commands go under the radar of Defender. So Born Again Shell, if you're talking about how we did that for Offensive Notion, let's take a look at that. Build Windows runs on Ubuntu latest. It's not running Defender for Linux. So it goes under the radar of Defender by not engaging with it at all, because it's not on a Windows machine. We're using Ming W on Linux to build for a Windows target. And so with Rust, what you do is rust up target add, and it handles the build pipeline for that. It's really, really easy. Honestly, this is literally all you have to do to build to a Windows target in Rust, all else being equal. Cargo build, set it to release, give it the target. It's called a target triple, which is architecture, target, and then libraries. So here it's like x86, 64, PC, Windows, GNU. On Mac OS, coming soon, it will look different. And then you just run it, and it'll build an exe for you, even on Linux. And now building from Linux to Mac OS is way freaking harder, and it's harder enough. Good syntax, Taggart. It's harder enough that we actually do burn the 10 times time on using a Mac OS machine to build it. We figured out how to do it on Linux, but it's annoying, and so we just ignore that and build for our Mac build for Offensive Notion. We just build it on a Mac machine and call it a day. Okay, so now I want to try to do this thing on a Windows box, because who knows what's going to happen, right? Now, in order to do this on a Windows box, I'm pretty sure, I don't know, but I'm pretty sure we're not going to get which CPUs were used. I don't know. They're Azure machines, so presumably they're virtual Intel CPUs. I still have a shell. Hang on. I stand corrected. It's an AMD EPYC 7763 64 core processor. But we only get one of them. Is this running on bare metal? That would be crazy, right? Can you skirt around the resource limits of the GitHub actions? I don't know, but you're more than welcome to look in the documentation to find out. No, they told us that they were virtual machines. They told us they were virtual machines. If M1s on bare metal work well, I am certain that they're not doing that. I am certain that they are virtualized. They're virtualized, and it's like Big Sur on an x86 processor. They're not using M1s for that. Okay, let's what happens if I exit out of this? Does that just work? Probably not. Let's go back to our actions. Oh, snap. Okay, so exit actually successfully ends it. Good to know. All right, so we'll do that from now on. Now, next challenge. Let's see what happens on Windows. And here we'll make a new branch. Okay. And then we'll change up this push branches not to main, but to Windows. Pull request doesn't matter, but fine. Windows, cool. Run on Windows. Runs on. I'm pretty sure there's a different syntax for this. Right, because I should have known that. We're not doing that. Runs on. Runs on. To find supported configure options for GitHub hosted runners, see virtual environments for GitHub hosted runners. Windows latest. Oh, by the way, here you go. This answers your question. By the way, so you can actually use your own self-hosted runners if you want to. But Windows Server, Windows latest. iPie, or LPie, I should say. Thank you so much for the follow. Yes, I recognize that as Pi. So there's a whole documentation on what's installed here. That's really cool. IP addresses are hosted in Azure, subsequently have the same IP address as the Azure data centers. I mean, it's telling you everything you need to know about this. Here, have some documentation. Linux and virtual machines have 2 cores, so this looks pretty locked in. Doesn't look like you can change this. 2 cores, 7 gigs of RAM. Why? And 14 gigs of SSD space. And for Mac OS, it's a triple core, 14 gigs of RAM, and 14 gigs of SSD disk space. More than sufficient for, you know, most offensive operations, right? All right, so we're going to do this. And now we're going to do run. And we're going to try this. Actually, Echo should still work. You got there beefier than some of my own VMs. I know, right? That was why we decided to go to GitHub Actions for most of the builds. Like, why not? Okay, so right. Literally this. We'll just try the PowerShell. We're going to get push u origin Windows to create a new Windows branch. And let's get the netcat listener going. Like, AMPC should shut us down on this one. I'm pretty sure. I'm pretty sure. Job is waiting for a hosted runner to come online. So it does, that does happen. I'm like checking my email to make sure I don't have any angry emails from GitHub. So far, no. Okay. All right, we'll let this kind of do its thing. We've actually never, I guess we've never tried to do a Windows build. There we go. I don't know why the checkout's taking so long. Oh, because they're setting up Git. That's very funny. I don't know why you would want this, but I'm just curious what happens, really. That's all I'm doing is just testing to see what it looks like on a Windows system when we have this capability. Authorization basic. So that failed, but one of the things I love about this is that you actually get error output. So what went wrong? Expression was expected after parentheses at car 1 line 129. You think it was the quotes? I think it was the quotes. Let's see what happens now. Now, the other thing I did want to play with tonight was, well, I'll let you decide. We could either do Docker for automated builds, which is always fun, or Azure DevOps. I have no idea what's going to happen in that environment. I really don't. That's the one that Lapsus compromised. What do you think, chat? Azure DevOps seems same as GitHub Actions. Ooh, the term equals is not recognized as the name of a commandlet. Wait, what? It's not multi-line though. It's a single line. No, John, I'm not. I'm not running Azure on the Proxmox machine. I mean, we had this in double quotes before, which was the problem. Go the whole thing, let someone else investigate it for once? Oh, interesting. You know what? I don't hate that idea. But we have to do it the CyberChef way. Pop quiz, why do we have to use CyberChef right now to do this? You are all set bit 64. Close technique. Also, thank you so much for the WTF bin submissions. Nope. Ginger's got it. UTF-16, or also known as wide characters. Windows encodes wide. Linux does not. So that's you ever decode base 64 commands and you get all those dots? That's why. Because you're decoding to UTF-8 instead of UTF-16, and consequently, you've got essentially extra bytes between every character that aren't printable. So the first thing we have to do is change the format here. Unicode text format. Nope. Come on. I always forget which one of these it is. There's like a Unicode. Nope. Nope. I just did that one, didn't I? Nope. Come on. Oh my god. Thank you. Encode text, right? Encoding to UTF-16 Little Endian. That's what I wanted. Okay, so now that we have that, we can do base 64. Oh my god. There it is. All right. Not env. I see it. I see it. Haven't used Windows in 5 years. I found it similar with Stall Arch. Hey! Everybody point out the Arch user. Let us know. SM Flores, you made it like an hour into the stream without letting us know that you were an Arch user. Well done. Hold on. Well, friends, we have a Windows shell. Your idea worked, indeed. And we can get system. We're in PowerShell. What is it? Get MP computer status for Defender. Yes. I learned my lesson. Husky, are you paying attention? How is the chicken, by the way? Okay, the anti-malware service is enabled. Antivirus is enabled. Behavior monitor is disabled. Okay. I'm so torn. I so badly want to drop Notion on this thing, offensive Notion on this thing. Is tamper protected equals false? Tamper protection source. Is tamper protected? You're right. I can just turn it off. I can just turn it off. Thanks, Technique. I'm just looking these up because there's so many. There's like 3 different commands, right? Yeah. Set MP preference, disable real-time monitoring, true. And yeah, there we go. Never send. So that's AMPC, right? Oh, it says antivirus enabled is still true. Oh, you know why? Hold on. No, because I am in a high context. I should have admin powers. Oh, but real-time protection is disabled, so we should be good. Was that enabled before? No, it wasn't enabled before. All right, screw it. Ooh, okay, we are gonna... Yeah, we're gonna do this. Sorry, just thinking. Because I can only run one ngrok connection at a time, right? So I think what I want to do with this is shut down this shell, but use what we've learned to build out the next part of this. The next part of this being we are going to deliver a meterpreter shell to this thing, and see what happens. So in terms of what we want to do, we're going to build the payload, MSF Venom. We're going to do Windows, thank you. Output's going to be mt.exe, that's fine. The L host, however, is going to be 4.tcp.ngrok.io, and the L port is going to be 11973. Okay. Very good. So in terms of things that we need to do now, little bit different. We're going to Vim our workflow, and now we have to make some more steps. So you can see how we have these different commands, right? So the next one we're going to do is name disable defender real-time monitoring, which was off, but just in case. And it's run, right? PowerShell C, and yeah, set MP preference, disable real-time monitoring true. We'll put that in quotes, which should be fine for this. Okay. And then the next one would be name disable sample submission. Okay. Now this mt.exe. Ooh, check that out. My shell died. Look at that. You can see the commands that I sent in XML. That's so interesting. Okay. But now we're going to execute the reverse shell a little bit differently. Tell the children went to a nice server farm in the country. Yeah. So we're going to knock that off for a second because we don't need all that just yet. What we are going to do, though, is save this out. And for our mt.exe, let's fire up Thunar here. Okay. We're going to rename this mt.exe, mt.txt. Why? Because Notion doesn't like exes, but it doesn't give a rat's ass about text files, even if they're not actually text files. So here's my good old Notion page. Drag and drop this thing. And when I click on it to download it, like go into my web history. Hey. Do I have to actually download it? Hold on. There it is. If I open, look at this. If I get my URL here. Copy link address. Thank God. Okay, there it is. So I'm going to take that link address and download it. Invoke web request, URI. And file name equals let me just make sure this URL works as written. Nope. Oh, I forgot the closing quote, didn't I? ID equals get object. Need the whole thing. All right, let's try that again. Crap. The request signature we calculated does not match the signature you provided. There it is. The quote was messing me up. So that actually works. Okay. So then out file. By the way, these links are good for 24 hours. Out file mt.exe. This is the base 64 encoded command I want. And yeah, we're going to let this hit the file system because we want to see what happens. So I'm going to call this download payload. And then there's our base 64 encoded. And then name, execute, run, mt.exe. Now, if this works, I'm going to need to set up, because ngrok is still doing the thing for me, but I need Meterpreter to capture the payload. So I need to set up Metasploit to listen for me. Use exploit multi-handler options. Yeah, obviously we have to change all of this. So set payload Windows x64, the old Magix Meterpreter. Reverse TCP. Set lhost quad zeros, because we're listening on, we can't listen on ngrok.io, so we're just going to listen on everything. And then set lport to our quad nines. Do you need use basic parsing on the end of that IWR since it probably won't have run the first time? That's a good question, Technique. Let's use it and not guess. Really good point. Okay. Oh, I did a stupid thing. I'm gonna have to recopy the text. Okay. Great. Yeah, good call, Technique. Looks good. Column 7, column 7, column 7. I was just making sure that my YAML was aligned because that would have driven me absolutely up a wall. Our shell died, so we can actually set up our Meterpreter listener now. And All right, so we're disabling defender stuff. We're downloading the payload using PowerShell. So SM Florist, basically what you're looking at here is the PowerShell. We're using its wget, or its curl, but the PowerShell command is invoke web request, right? So if we look at the PowerShell command, it's in IWR, also known as invoke web request. We give it the URI parameter, just like we would give, wget the URL. Out file, tac o, give it, empty.exe. And they use basic parsing. So the way that invoke web request works is that it uses the Internet Explorer engine. And so Technique was right. If this is a, baby fresh VM, Internet Explorer will never have run before. So we have to tell it to use this basic parsing mechanism, not Internet Explorer, which bypasses that whole problem. But yeah, it's just command line stuff. It's just a different shell. But one cool trick with PowerShell is that you can base64 encode the command, so you don't have to worry about like quote stuff or variable expansion, things like that. And so we are taking this command and base64 encoding it for ease of use in our payload. Okay. Okay. Git commit am. Test MSF, git push. Like, there's no way this works, right? There's no way this works. We didn't get very far at all. We failed on the real-time monitoring. Cannot process argument transformation on parameter, disable real-time monitoring, cannot convert value system.string, type system.boolean. Ooh. Boolean parameters accept only Boolean values such as true, false. I think it's the double quotes on that one. I do. I think that one's the double quotes, which is fine. We can fix that. Yeah, because the double quotes are doing variable expansion. And we don't need them for this. Actually, I don't need quotes at all, to be honest with you. Quotes. I wonder how many times I've made that exact commit message. It's definitely more than 3. Mm-hmm. Man, Night Ride is killing it tonight. You're listening to Ace Buchanan's Mizukage Prototype. Oh, come on. Should it be capital T? These are coming up fast. Okay, they were. I shouldn't have said anything. Oh, it looks like it's stripping the $sign for some reason. Maybe just encode those two. Yeah, maybe. That's a good idea. Or like escape. Oh, yeah, because right, $signs are getting interpreted by the YAML. Maybe escape the $sign. We'll see if the capital... It shouldn't have mattered. I predict, Technique, that you're right. Except insanely no? Yeah, there we go. Okay, it was like... Took a while to error out, but I think you're absolutely right. That we're gonna... escape this $sign. Yeah, if we need to base 64 encode it, we will. I would rather not, but... This feels more like how the first few builds with Offensive Notion went, where we were just like, do it! Push! Go! Just sent as many automated builds, and we were very thankful for the lax billing policy on GitHub. It is straight up taking out. Yep, okay. Base 64 encode everything then. Fine. Yeah, no profile. That doesn't matter in this case. All your base 64 belong to us. Hey, the Guar. Okay. There we are. It's like, which tab do I want here? That's the ticket. Great. Okay. And then we'll do here. Oh, somebody just found the Python emote. Yeah, they did put a space there for me. Thank you, Vim. I love that I can fire PCAPs directly into CyberShaft with Security Onion. That is cool. B64, all the things. Ink on the disable is missing. Technique has got my back. Thank you. Building the grid. The grid. I bet you 40 nodes. I'm excited that you're moving beyond standalone, Dagor. It's a fun time for you. Oh, I can just do amend.
Video games are addictive, like drugs. There is
Nope.
true physical dependence. Maybe it's a warning.
We'll amend that commit because we didn't push it. If I can spell amend correctly. Now, for the love of all that is holy. I'm just trying to exploit your infrastructure To pop a shell. Is that so much to ask? Fun. Yes, I'm glad we don't have any D-Link. The amount of CVE attacks I see coming for D-Link exploits is crazy. Oh, yeah. Well, watch out for Apache struts, too. That's another fun one that you'll see a ton of. Yeah, once you start listening for stuff like that on your internet-facing ports, the amount of evil that you see people just shotgunning across the internet is quite upsetting. I'm sorry. What? Oh, but it died immediately. So, presumably, Defender was actually doing its job at that point. But we did get the shell. So let's see what happened here. Download payload, which it did. Execute. So Defender, I think, was still catching us. Windows Server 2016, you could try uninstall Windows feature in the Windows Server anti-malware. No. How did I base 64 encode it? It caught it as a behavior. Defender was still working. Understand? So it wasn't that the antivirus signatured it and knocked it off. It was that Defender saw the TCP going out and knocked it off, which happens constantly. So, but because real-time monitoring wasn't actually disabled, I think is what happened. We can't uninstall Defender, right? This doesn't work. SE stop WinDefend. That can't work as an admin user, can it? I don't have to guess. I am one. I'm in a medium. I need a... get service, win defend, stop service, pass through, but it said it didn't work either. Yeah, that's not actually working. That's okay, though. We just have to, I hate to say it, but try a little harder. Would it still be knocked down with an exclusion added? I don't know if you can add an exclusion. Here's the deal. It's signaturing the bytes of the interpreter shell as it's going across the wire. I'm pretty sure. Or as the process is loaded, I should say, is really what's up. So instead, we can try another little trick of ours. No, Ginge, it's not. I mean, we'll maybe Windows Defender MC and run, remove definitions, all, set MP preference, disable IOA. You know what? Let's try it. Let's try it. But if this doesn't work, I do have another plan. Okay. Yeah, if this doesn't work, the other thing we could try is get the action going here. Is use our little NIMjector tool, right? That was written in NIM, and basically what it does is we'll base64 encode the payload a few times, and we will get it past, because it won't see the bytes of the interpreter payload until we're on the system, and up and running. And because it's encoded 3 times, it just doesn't bother. So if we need to, we can do that. Failed now. What happened? Unexpected token, remove definitions and expressions or statement. Interesting. Okay. You know what? Let's give that a shot. So, do I have that thing somewhere? That's the offensive notion stuff. Let me go to NIMjector here and go get the code from my gist. It's a very GitHub heavy night. Thank you. Vim NIMjector.nim. And was it Technique who taught me about the cool set paste thing? I think it was. But if not, whoever it was, thank you so much for that. That's a cool trick I learned. Okay, so how are we going to do this? We need to be able to, yeah. So we're going to download note.txt from Notion. Which is fine. We have to modify this a little bit, but that's okay. We actually don't need SC port. We don't need the address. We're going to do let SC URL, shellcode URL, equal whatever it is, and we'll go deal with that in a second. And it's kind of it. And then what we'll do base64 iterations equals 3. And what this does, is pretty cool, is it will go and get triple base64 encoded shellcode in a certain format, which you'll see in a second. What we'll do here is we're going to rerun MSF Venom. But the output, or the format, is C#. See why in a second. And the output is going to be mt.cs, just because. Same stuff. Okay, 1014695. Or no, sorry, payload size is 200262, which is usually what it is for this. Okay, we need to put that down in our... Yeah, this is for, like, Cobalt Strike, which is way tinier. We have to manually allocate the array. So we just set that up here. And then what this is going to do is... CURL. We'll change that up. Okay. And then, so it's going to download that code from Notion, which once we put it there. You can use encoder x86 XOR dynamic with MSF Venom if you're doing a 32-bit payload. You cannot do that with a 64-bit payload. Well, actually, the XOR you can, but unless you do it a billion times or something like that, Defender's going to catch you anyway. It just doesn't care. It has a bunch of signatures for XORs. Okay, so this is good for our NIM here. We're not finished with it yet. Actually, let's leave this open. And then we have to vim mt.cs. And what we're going to do with this, we're going to delete the first line. And we're going to delete the junk off the end. Okay. Then we are going to replace every new line. Oh my god. Oh my god. With a new, with nothing. So see how we have those line numbers over here? They're about to go away. Right? We have one line. Okay. Now, we're going to pipe that to base64 without a word wrap. And we're going to do that 3 times. Still one line of base64 encoded data, so we don't have to worry about any junk. And don't forget, so we'll save this as note.txt. Okay? Now let's vim mt.cs. So you can see that I've got these 0x's, right? And I've just basically created a big string. Well, what the nimjector tool is going to do is it's going to take that information, decode it we tell it how many times we base64 encoded the thing. It's going to split the string on commas, which we've just given it. Then it's going to parse hex int. It actually knows how to read 0x. NIM's parse hex int function knows how to read the 0x's and turn this into a proper integer, which means we can turn these into raw bytes and therefore give ourselves some shellcode. And that is exactly what we're going to do. We're going to create a remote thread on notepad.exe, I guess. Yes. Yes. Because this starts the process for us. So it's going to start Notepad, and then we get to inject into it. So all that's left is for us to get the URL of note.txt, which we're going to do the same way we did before. And there's note.txt, so let's get Thunar up and running. Oh, I already have it up and running. Cool. Let's go over to Notion. All right. Can actually delete this because I'm not using it anymore. But let's give it note.txt. Again, works great. I click on it. This insanely will actually give me the raw text. It doesn't try to download it. And I'm just going to copy that as my URL and put that in my SC URL. Save this. We're going to do nim c with the compiler flag for mingw and give it nimjector. And actually, I should have given it the debug release as well. So it's nice and small. Okay, so there's nimjector.exe. Now I will also have to move that. So if we... Let's cp scripts nimjector.exe to nimjector.txt. I'm not trying to hide what I'm doing here in this case, so we'll just call it nimjector.txt and put that on our Notion page 2. Okay. So we're going to go get this URL. Copy link address. Go over to CyberChef. Invoke web request. URI. Out file. mt.exe. Use basic parsing. Okay. And then I can close the nimjector pane. I don't need that anymore. Now I'm going to change up my workflow, because now to download the payload, we have our new download payload, which will still send it to mt.exe, right? Because we wrote our file mt.exe here. The only difference is that now we've got this shell code that instead of being raw is base64 encoded, being watched by it's being watched by a defender, but it's missing it because once it sees the triple base64 encoded, it'll try once, twice, but it won't try 3 times. So in fact, we're gonna remove the disable defender. Okay. Git commit am nimjector. Okay, let's make sure that our TCP handler is running. Push. And I think we're good. This is why I use... Ooh. Oh, interesting. Oh, Taggart, you idiot. That was my fault. There was no problem with our command at all. It was the nim payload, because I forgot to compile it with SSL enabled. Yep, one more compiler flag, D, SSL. Good. Now, we're going to have to go modify that up here. We'll remove nimjector.txt here. And re-upload it. Okay. Save that and get that URL. Copy link address. And that's what we get in our base64 encoded, right? So good. All right, so we'll go grab copy this. We're close though, friends. I think we're really, really close. Chat, you're quiet. Please let me know if you have any questions. Still running, good. The reason we use nim for this is because it's a very easy programming language with a lot of power to do stuff like this. Could I have done it in Rust? Yes. Did I want to? No. You're trying your hardest not to run everyone off. Why would you run anyone off, John? Oh, whoa. Look at that. No TLS, no SSL TLS CA certificates found. Huh. No TLS, no SSL TLS certificates found. That's wild. Now, there is a way to fix that. But I kind of want to move on to something else, where we've obviously demonstrated that we can gain code execution on both the Linux and the Windows side. In terms of Defender bypass, you know, there's some work to be done there, but that's basic Windows AV evasion, right? Which is exactly what we're doing. That's not really new, as Husky would say, new tech. So I kind of wanted to move over to Docker real quick before we said goodnight. And the way to do that is we're going to make a Docker file. This is kind of cool. So we're going to move away from GitHub Actions for a minute, and we're going to talk about Docker. So Docker is great, and it allows you to containerize applications. It allows you to build your own Docker image, which you could deploy wherever. Here's the thing about Docker images. They are built from these things called Docker files, and Docker files allow you to run arbitrary commands. You have to, because you're configuring the base image that you're going to use for your running application, right? So, let's head over to, let's just make a Docker file, right? Docker file. And we'll do from Alpine, because it's really tiny, latest, which is a Docker base image. And you can find them by running, if you have Docker installed, you do Docker image search if you want, or I think, right? Docker image search Alpine. Nope, my bad. Never mind. I thought you could do that. If you want to search for available Docker images, you go to hub.docker.com. There are other container repositories, but this is kind of the free and open one. And you just search. Right? Search for Alpine. There's the official Alpine Linux Docker image. It's very tiny. Love it a lot. And it's perfect for something like this. Now, it has its own package manager. So apk add, if we wanted bin bash, if we wanted, for whatever reason. So let's actually do that. Let's run apk add bash. And then, just so you can see what this looks like, entry point bin bash. And the entry point is the command that it will run when you tell the Docker container to run. Very, very simple Docker file. Nothing special going on here, but I just wanted, as a proof of concept, let's use that. All right. To do this, we're going to do Docker image build, call it bad idea, and give it the current folder as the build context. The reason we do that is that it's going to look for the Docker file in this folder, find it, and then do something with it. Build our new Docker image. What images do we have right now? Docker image ls will tell us. So I have Ubuntu, I have MySQL, I have this, oh yeah, I have this log4shell demo app from, months ago. Viper Monkey, I don't remember what that is. And then OpenVaz. You know what? I can do Docker image prune and clean some of that up. Okay, never mind. But let's build a new one. So the first thing it does is it gets Alpine, downloads it real quick, runs bash, or add bash, right? Entry point bin bash. We've just made a new Docker image. Now, it is local to our machine. But if we look at Docker image ls here, now you can see that I've got bad idea. And if I do Docker container run, we'll do it with the interactive and give it a sudo tty, I should say, so that we can get input output. And we'll run bad idea. And I don't even have to give it a command to run because its entry point is set to bin bash. And because I'm running in interactive mode, it should just give me a shell inside of the container. Indeed it does. That's how Docker works. And when I exit, I should have actually done it with a --rm, because now I have to do docker container ls -a to find stopped containers. And I'll do docker container prune to clean up all of those. Great. Okay, now, how can this be used for evil? Well, obviously, if I have a run command, then I can give it a reverse shell, right? I've installed bin bash on this thing now. So let's vim Dockerfile. Okay. And then let's run. Oh, just kidding. Yeah, well, what we'll do is git checkout to our previous branch, right? We'll vim the Docker file, and then in another tab, we will do GitHub workflows, bad idea, YAML. So I'm going to go pull my run command here right out of the GitHub action. And just change that up a little bit. And we'll never get to that entry point. So what happens here is when we go to build this Docker file, or this Docker image from the Docker file, Docker image build, right? So I'm not running well, I am running containers, but they're part of the build process. What should happen, let me, we did get an interpreter session, sort of. No, we didn't. That was from ngrok being weird. Is NC default installed? Oh, good question. Let's find out. So we'll do Docker container run, and we'll run it with the --rm, so I don't have to delete the stopped container when it's finished. Why, yes, it is. It's even installed with the -e. And yet, here it is. Not even ping? You sure about that? Ping is installed in Alpine. Oh, yeah. So we actually have netcat ready to go. So we're going to do Docker image build. And if all has gone according to plan, we're going to get our netcat listener up over here. If all's gone according to plan, this thing will hit our ngrok. It's a little bit funky because I'm going out and back, right? I'm going out to the internet and back into my machine. But nevertheless, it will give me a shell here if all has gone according to plan. During the build process, which is the point. Look at that. So we just got a shell during the build process. Okay? Now, why is that scary? Because I can set up builds in the cloud. If I have Docker Hub set up, I can do this a couple different ways. Totally blanked on where I was for a second. Yeah. So in repositories, what we're gonna do is make a new repository here and call it bad idea. It's a really bad idea. Now I pay for Docker Pro so I can get private repos, which is exactly what we want to do. And we'll talk about automated builds in just a second. Auto build triggers build anew with every git push to your source code repository, which is exactly what we want to do eventually. And actually, let's kill this and kill this. And git checkout -b Docker. So now we're in a Docker branch. And don't forget that we're only we should only run the workflows on pushes on main and pull requests on main, right? So we shouldn't actually trigger the GitHub action on the Docker branch. And let's confirm that. We'll do git push u origin Docker. We haven't done anything. We're just making the branch. This is in GitHub. So we go to bad ideas. Okay. There's a Docker branch and actions. Nothing is running. That's exactly what we want to see. Fantastic. Now, I do want, however, to connect. So let's git add Docker file and git commit m add Docker file. Not particularly inventive. We'll git push that up. Okay. Well, I'm a sucker for recitations like this in music. It's cool. There's a band I like called Saltillo that has like entire sections of Hamlet in it, set to an awesome beat. Okay. So coming back over to the Docker Hub as we're creating this repository, and again, the scenario we're imagining is to beat or not to beat. Ooh, Cheeto Bandito. I don't know about that. The idea we're imagining is you've compromised somebody's CI/CD pipeline, and you get to inject commands into a Docker file or wherever else, and you're able to compromise things. What's crazy about this is that there may be secrets available to you in these environments, or you can kind of pivot and use these platforms as your attack platform. So let's create this repo and go to builds, and we'll link to GitHub. It's just me and bad ideas. There's my connection to the source repo, and the build location is going to be on Docker Hub's infrastructure. Awesome. We are going to build on the source branch of Docker. The Docker tag will be latest. The Docker file location is in the root of the repository. We're going to auto build it. That all looks good. We are going to save and build with our netcat listener up. And if all has gone according to plan, actually, just kidding. Let's run the netcat in the big window over here. If all's gone according to plan, we should get a shell in the Docker Hub. So it's starting the build process. It's spinning everything up and getting us ready to go. Hi, Bite Sprite. Good to see you. No, I will not be starting over. But I have to tell you, this has been a very cool stream, if I do say so myself. We've done some really neat stuff. Okay, it's pending. Docker file's not available yet. Let's go, Docker Hub. What do I pay you for? By the way, in case you're curious, like, what does Docker Hub Pro cost? It's like $7 a month. And what that gives you is private repositories and automated builds in your private repositories, things like that. If you use Docker a bunch, and I do, it's totally worth it. Come on. Great, in progress. And there it is. There's our shell. We have internet access. Oh, interesting. Curl's not in here, but we do APK add curl. Right? Yep. Curl HTTPS api.ipfi.org. 54.242. That looks like Azure, right? No, EC2. So, you now have an EC2 instance. All right, so we've just demonstrated that you can use Docker files to actually get yourself a shell on Docker Hub's infra, right, during your build process, or a malicious attacker could try to do that inside of somebody's CI/CD pipeline. In order to, and this is we're getting a shell, but you can imagine all kinds of malicious stuff we could do. You could inject things into environment variables. You could disclose environment variables, right? Metadata time on AWS. Oh, that's a good point too. Right. This one's actually a little bit easier, right? Yeah. Identity credentials. Isn't a common attack vector for the hack to work from a Docker session? It depends on what you mean. There's the account ID. Now, without secrets, you can't do much with that, and that's as far as I want to go with that. But obviously, the API, the metadata API is available, right? Or kill that. And this build should die. Actually, it might succeed. It would be a private area for them to extract data and credit from there. Yeah, it can be. It depends on what happens. But in order for you to get access to the root file system, you have to mount it inside. And any read-writes that you see happen there would still be registered by the top-level file system. I would say WSL... The container has access to VM metadata. Yep. It did. And that's not so surprising because the networking rules aren't preventing it from doing anything crazy. I'm going to cancel this build and also delete the repo because I don't need it. Bad idea. Okay. So I think we're going to call it a night, friends. Having demoed both Docker and GitHub Action CI/CD compromises and attacks. This is really scary stuff, and I think that we should think carefully about how to notice these things. How do we defend against these things? Obviously, a lot of it comes down to controlled access. Who's allowed to see your repos? Who's allowed to make changes to them? Where are secrets kept? Are you making sure that they are kept securely, that they never leak into repos proper? And do you have any sort of, if you're doing builds on-prem, are you monitoring what's going on? Is there proper code review, even at scale? That's what got SolarWinds, was that they had code injected into their products that they didn't notice because it was part of an automated build process. And that's the kind of thing that can really burn you. So, all right, I think that's going to call it a night. That's going to do it for tonight. Thank you so much for hanging out. I hope you learned something. I know that I did. Looks like Cyber Tech Vibes is streaming right now, so we're going to go ahead and give them a raid. If you don't know about the hack list, here it is. There are lots of us InfoSec streamers. Go check some of them out. And right now, let's go check out Cyber Tech Vibes. I will be back tomorrow night at 5 p.m. Pacific doing some programming, so we'll see you then. But until next time, friends, be good to yourselves, be good to each other, and happy hacking. We'll see you next time.